Hello, review problems for chapter 16 here on page 571. We're looking at number 1 first. How are conductors different than insulators? The main difference between a conductor and an insulator is that conductors allow charges to conduct through them. A conductor, such as your classic metal or water, allows the charge to move through it, whereas an insulator can gather charges on the outside, but you cannot pass a charge through them. That's the main difference between conductors and insulators. Number 3. A negatively charged balloon has a charge of 3 microcoulombs. How many electrons does this balloon have? So let me pause and write those numbers on the board for a second. So we got 3 microcoulombs is 3 times 10 to the negative 6th coulombs. To find out the number of electrons in any given charge, you need to multiply by the big number, 6.2 times 10 to the 18th electrons per coulomb, and then you can see that your coulombs cancel, leaving you some large amount of electrons. Number 4. Would life be any different if we switched out positive and negative? No. The answer is no. The only difference would be when you're learning chemistry, you have to learn that their positive and negative are switched. The fact that they're opposite charges is all that matters, and that's what good old Ben Franklin figured out for us. He figured out that they were opposite charges, and he called them positive and negative. In this case, positive and negative are simply labels. They don't have a mathematical significance. They're just labels. Number 5. Explain why charges transfer with electrons. In the terms of an atom, how often did you remember learning that protons were moving in atoms? You simply didn't. Protons don't really move. Therefore, electrons need to be the ones that are moving. Number 6. Because of a moisture content in summer, it's harder to get a charge built up. Summer air is a better conductive charge. Winter air is better at holding charge. This is because the water in the air allows for charge to travel through it a little better and unload it. So you don't get as many static shocks in the summer as you do in the winter. Number 7, a balloon is negatively charged by rubbing and then clings to a wall. Does this mean the wall is positive? No. What it means is the balloon is negative, and the negatives in the balloon are attracted to the positive parts of the wall atoms. The negatives in the wall atoms kind of run away a little bit, but they don't go away. They just kind of rotate. It's called polarization. And then number 9, what determines the direction of electrical force between two charges? Well, that has to go with the sign and whether you're talking about a positive and negative or positive, positive, negative, negative. So you have to look at, if we have a positive and a negative, the answer to our force problem will be negative. So they are going to be attracting each other. They're pulling on one another. If you have two positives, your answer will come out positive in also, and you will have a repulsive force. Same if you have two negatives. So the sign of your electric force problem will tell you if you are attracting or repelling, and that's what you have to pay attention to. That'll be the end of this recording.